Welcome to the Learning Design Patterns Through Games tutorial series. I'm Braden, Coach Carter, and I'll be taking you guys through a handful of design patterns, how they work, and demonstrating how they can be used inside of games. So today we will be looking at the strategy pattern. This design pattern is used to kind of take like functionality and encapsulate it together, and then make that functionality interchangeable at runtime. That way you can kind of swap things in and out as you go. So with that being said, let's hop into the project that we have to demonstrate this concept, and we'll get started. So a quick play, we'll open it up. As you see, we've got a nice little target range set up. We move forward. If I left click, you can see we shoot one bullet, one little arrow. If I push the F key, you can see it switches to a 3-burst mode. If I push F key again, it switches to a full auto. Pretty common setup in most first-person shooter games, especially with rifles. So we'll take a look at what code is actually running right now. What we're going to do is take this code, we'll refactor it into the strategy pattern, and then we'll see how the code that we come up with now is a lot more interchangeable and a lot easier to update and maintain. So taking a look at this one, we have a simple enumerator with each of our firing modes. This is where we were toggling between single burst, full auto. These two lines here is just for how quickly the gun fires. This is where we say, what are we firing? This is where we're firing from, and this is how fast that bullet's moving, and just if we're currently firing. Start mode, cursor, this is just keeping the cursor in the window. This is where all the core of the stuff goes on. F key for toggling between our firing modes. Calculating how long it takes between bullets so that we're not firing every frame, but we're firing like once every 1/10 of a second or whatever value we specify. And just an if check to make sure that we can fire that when we push that the left mouse button down. If we do, we reset the timer back to 0, and then depending on what firing mode we're in, we handle that logic and pass it through to fire single shot. This just creates an object and then adds force to make it go forward. Full auto, same thing. It looks exactly like single shot stuff. And that's where refactoring into the strategy pattern is going to really kind of help clean up our code, because there is this duplicate code here. And then fire 3 bursts, this is just the 3-burst code. Again, looks very similar to all the rest. So the main issue that we have with this code is if we go back into Unity and let's say that we want to take let's say we want to add a pistol into our game. So we create a new object. We're just going to duplicate our rifle for right now. We'll remove that script. We'll create a new script called pistol. Put it onto, once you pause, thank you very much. Put it onto our pistol object, open it up. So we're going to bring over a few things that we have from this one, namely all of our gun attributes. And we left the is firing because that's actually critical for the pistol itself. And then we don't need anything in start. We don't need the firing mode stuff because the pistol is just going to have one single shot fire. And so inside of here we'll grab the time since last fired so we don't fire every frame again. Our if check to make sure that we're doing it, reset. Reset the time, and then we will grab our single shot code and just say fire single shot. One last thing we need to do is add get mouse button up 0 is firing equals false. So that's just going to make us that we don't fire constantly. that you have to pick your finger back up to shoot. So that's our pistol code. It should, assuming we get rid of, or we add our proper curly braces in, I've actually got a weapon switching script already set up for this. So we'll add the pistol. We'll have it off by default. Play. So we're still on our rifle. We'll switch over to our pistol. You can see it's different because our projectile force is 5 instead of 1,000, which is what we had set before. So we'll change that. Here's our pistol. It's great. It works. You know, it wasn't too bad to do, but the main issue that we have here is there's a lot of duplicate code. You know, specifically in the fact that if we needed to change, you know, let's say we moved forward with this, we created 50 rifles and 50 pistols. So we've got 100 weapons now. Let's say we found a bug in our single shot code. Now we have 100 places that we now have to change that code because we needed to make one minor change. You know, let's say we forgot to add this physics call, and so our bullets were always colliding with the player. We have 100 places we have to do that now, which is tiresome, a huge maintenance thing, and it's what I like to call the swamp, because you made one change, but now you're bogged down, and your development becomes a lot slower because of the way that your code's structured. So what we're going to do is we're going to refactor this code. That single shot code now gets reusable, and we can put it on any weapon. We can interchange it however we like. You know, we'll retain all of our functionality of changing out the multi-shot, or the burst fire, the full auto, the single shot. So that way, through the life of the development, if we have a bug, we have one place to change it. If we want to add new behavior, we just create a new behavior and it's good to go. So to start, what we're going to do is we're going to make an interface. We're going to call this our fire behavior interface. Actually, let's call this firing behavior. An interface is just an easy way to give certain scripts attributes that other scripts can tie into without actually having to know this specific class. And it beats, it's a lot more flexible than a specific class inheritance because you can only inherit from one class. So, but you can put as many interfaces on a single class as you like. So we're going to start with our firing behavior interface. We'll say public interface firing behavior. We will just add a simple fire method. So normally, if in most programs, that's all we'd have to do for our strategy pattern, because our new weapon will handle all of the our new weapon will handle everything else after the fire. But since we are working in Unity, we'll need to do a little bit more for our behaviors, just because they'll need to know what projectile that weapon's using, etc. You know, where it's shooting from, all of that information that we had before. Normally, I would pass this information through a constructor, but since mono behaviors don't have constructors, I can't do that, so I have to pass it through a method. You could do it through an awake and make a call to the weapon, but it's going to be easier if the weapon passes that information to the behavior. So we're going to also add an initialize method, or initialize method to our interface. We're just going to pass in the projectile that it's supposed to shoot, where we're shooting it from, and finally how fast we're going to shoot it. So there's our simple behavior, our simple firing behavior interface. So now we just need to create our different firing modes. So we'll start with single shot. We'll make a new method called single shot behavior. We'll bring this back up. First thing we're going to do, we have it as a mono behavior, no problem. So we need to implement our firing behavior interface, which will consist of our fire and initialize methods. Quick note for what I just did, if you implement an interface, or when you implement an interface, you have to implement all of the methods within that interface. So a quick and easy way to do that is once you put it into your script, if you hit Control period in Visual Studios, you can say implement interface. As you see, I'll do it one more time. because it will highlight over. It says does not implement interface member, so control period, implement interface. So for our fire method for our single shot, we will come back through. We already have the code for it done, so we will just grab our single shot code because that's all it's going to do. So we will add that into our firing behavior. I like to have my initialize methods up top, so we'll put it in there. Few variables that we need will be the references to these projectiles, firing, transform, and force that we pass in. So we will say projectile prefab, transform firing position, because these are the names that we use down here, and float projectile force. So inside of our initialize, we're just going to save that information, projectile prefab that we're passing in, projectile, firing position equals firing T, and finally projectile force equals projectile force, but since they're named the same way, we will have to add this dot projectile force in front. And one other thing that we need to add, before we had our input.get mouse button up for is firing in our update method in here, but in reality, like, this actually causes a bug with this burst fire, because you could technically, because every time we push the left mouse button down, I'll actually demonstrate this with our rifle. If we set it to burst fire mode, if we spam it, you can see that we actually will shoot faster than our full auto, or almost just as fast, which is not what we want. And you can see where that code being shoved into the same class causes that issue. So in our single shot behavior, we're actually going to add that up call, because it's only relevant to our single shot and our burst shot methods. So we'll add a bool, can be fired. By default, it'll be true. And then so we have that code, we have that set up. So if we are firing, then it can't be fired. When we fire it first, it can't be fired anymore. We will add our input .get mouse button up, left mouse button, and we will say can be fired equals true. So the nice thing of pulling this sort of information back into our behaviors is because this isn't required for our full auto. We can hold the left mouse button down and we'll continuously fire as expected. Really, we only want that pick up the left mouse button for our single shot and our burst shot. So by pulling it into here, it's relevant. It's within the same script, so you can see what actually needs it. And so it keeps all of our code that is correlated together. We keep it together, and by itself. So that's all we really need for this one. Before we go back in, we will need to create a new script for our new weapon. So we will call this just firing weapon strategy. Once this opens back up, thank you. This will still be a mono behavior. We will bring over the have a firing weapon. We'll bring over all of our code that we had before for the fire rate in seconds and all of that information. That'll still be used. What we will be adding, though, is we'll be adding a reference to that interface that we created. So private firing behavior, we'll actually do protected, because we'll end up subclassing this. So all of these will actually become protected. So we will reference that interface we created, and we'll call this current firing behavior. So in start, we will just initialize our firing behavior, our single shot behavior. So we'll say current firing behavior equals, actually we'll do single shot behavior, single shot equals game object dot add component, and we'll add our single shot behavior. We then need to initialize it with the information that we have. So we'll say single shot dot initialize. Oop, these aren't public. Our firing behavior, we need to specify that these need to be public. No, there's not. Okay, fine. Not sure why it's not liking these. What I'll do is just get rid of these for now. That should solve the problem. So we'll say single shot dot initialize. We'll pass in our projectile prefab. Pass in our firing position and our projectile force. We'll default this to 1,000 since that's the number we were using. And then we will say current firing behavior equals single shot. And then we will add back in our shooting codes, input.get key or get mouse button 0. We will say let's pull over this information. We're just going to add in our timer for making sure that we don't shoot too fast. We no longer need the is firing. And then we will say current time since last fired, and then we will pass our, normally where we had before we were saying like fire single shot, fire burst shot. What we'll actually do is pass this information to our firing behavior. So we'll call current firing behavior dot fire. That's all we need. If we bring this back in, fix our compile error, because apparently I keep missing brackets somewhere. Benefits of copy and paste. We'll duplicate our rifle. Let's disable this one to start. We'll call this our strategy rifle. We will remove this one, add in our firing weapon strategy, add our bolt back in, which turned into an arrow really, and then add our firing position. And when we start the game, we should be able to have that single shot behavior. As you see, we do, no problem. So we're still missing the other two. The other two will follow the same process of our single shot behavior, where we initialize it, fire, and add this. I've already got them done, so we won't refactor all of them today. You guys can check out. We'll go over the scripts quickly to demonstrate, just to show you that they look exactly the same as they did before. But rather than boring you guys with the rest of that refactor, we will just add these in. Burst fire behavior. These actually got removed. That got removed. And we need to add our projectile force back in. So a simple thing, like I said before, we just kind of brought our firing behavior, firing weapon code back over. We have our initialize, where we save our variables. We have our fire, where we create them. This is our single shot, not our burst fire. Same situation. Initialize, our fire. We started coroutine for creating one projectile every 1/10 of a second. And then just for the code for picking it back up, if we look at the full auto, it's going to be hopefully working. Wait, yeah. This is gone. This is gone. So same situation, nice and simple. Mono behavior, firing behavior. save our variables in our initialize, run our variables in our fire method. So let's go ahead and we'll add these back into our weapon strategy. Just for now, and so we will say, so we will actually make a list of our firing behaviors. We will say firing behaviors equals a new list. We will add single shot to that list. And now we will do our same thing for our burst and full auto. So we'll just move these over because they get initialized the same way. We'll call this burst shot. And then we will do full auto behavior, single shots. We will this will be full auto shot. So run its initialize, add it to the list. We will add in a index, private int firing index equals 0, and then we will just say current behavior equals initialize it to single shot, no problem. Inside of here, we'll add our toggling, so input dot get key up, key code, go back to that F, and we'll say firing index plus plus. If firing index is greater than or equal to the number of firing behaviors we have, dot count, we will set it back to 0, and then we will set our current fire behavior to firing behaviors dot firing index. And what I'm actually going to do is take these. We're going to extract these out into a method called initialize firing behaviors for that method, or for that class. I'm going to take you out, and we're actually going to swap this with firing behaviors firing index, which by default will be 0. We will make this protected so that our subclasses can inherit from it, and we'll make it virtual so they can overwrite it. So now when we go back to our weapon strategy, we still have our strategy rifle. We'll move the other one. So if our strategy rifle, you can see we have our single shot still works. If we move to, here's our burst shot, push F again, we have our full auto. So we're back to square one, but our code is actually a lot cleaner now. Because we don't have all of this code that's jumbled up in the same script for handling our, our burst fire is handled in its own script, its full auto is handled in our own script, and our single shots handled in its own script. So they can't maintain with each other. So if we have to make a change to one, we don't touch any of the other ones when we do it. And so if we move from here, we added a pistol back, or we added a pistol the first time. So let's add a pistol with this strategy behavior. So we'll call this pistol strategy. Otherwise, so we don't have a naming conflict. So our pistol strategy will inherit from our firing weapon strategy. Just so that we pull in all of our guns are going to have this same methodology here. We wouldn't have to inherit from it if we didn't want to, but I'm doing it just since we're going to use the same properties for our weapon. And all we're going to do here is I'm actually going to pull this back out. We'll go to our pistol strategy. For this to work, all we need to do is override that initialize firing behaviors. Our pistol will only have our single shot, so we'll grab our single shot initializer over here. Has a single shot, good to go, and that's all we have to do for our pistol. So if we duplicate our rifle, we'll add the pistol in, remove this off, add our pistol strategy, Let's do bolt in our firing position. Now let's say this is like, this is one of our hand cannons, so it only shoots every 1/6 of a second. It'll also give you that difference in, show you the difference between these two weapons. So we have our strategy rifle, shoots, sure, no problem. Here's burst fire, full auto. We switch over to the pistol. There's our shot. It only shoots one every 1/6 of a second, so it's probably a little long for this demonstration, but you can see. Let's just reduce this back down a little bit. So you can see that it shoots much slower. So quick, easy, simple. You can see how we reuse all of our same code for our single shot and just put it into for our pistol strategy. If we, taking the same example, let's say we wanted to have let's say we wanted to make a shotgun. All we have to do is make a shotgun behavior for how a shotgun fires. Add it right here, initialize it, and add it to our array that we have, and then we have a shotgun. Easy peasy, really simple. No easy. Beam weapons the same way. So, a good example of how this can work in classic game examples is Contra. When you get a pickup in Contra, it completely changes how your gun works. So you could do that by swapping out the weapon itself, or you can still have just weapon that handles all of the firing things, and then have a separate firing behavior for all of them. And so, you got your one shot that you start with, you pick up a power up, now you got the triple shot that goes, every direction from Contra, or you got like the laser beam that shoots forward. You can have one weapon and just swap out how that behavior, how the firing behavior of that weapon works, rather than having to make completely different weapons every single time. So that's a simple demonstration of how we can take our code and move it into a strategy pattern. So let's go ahead and let's take a look at how the strategy pattern actually works from more of a top-down level. So this is a UML diagram for the strategy pattern. A UML diagram is basically just a graphic overview of how a certain system architecture works. And so in this case, every box that you see is a class or an object. We'll start with the definition for strategy pattern. The little definition is it defines a family of algorithms, encapsulates each one, and makes them interchangeable. And you can kind of see how we did that when we defined our defined family of algorithms was our firing behaviors. We encapsulated all of them inside an interface. And then when we took it back to our context of our weapon, all of them were interchangeable because we just swapped out what object was going into that interface. But to give a more overview of this one, we have you have your context class, and then you have a reference to your strategy interface inside of your context class as a variable. And then you have a simple method that just says, interface dot do something. So in our case, it was dot fire, dot do fire. Ours was the input dot get mouse button down, firing behavior dot fire. That was ours in this case. The interface itself, our strategy interface, just needs to contain a method that's going to be run from the context that's going to do whatever you need it to do. So in our case, like I said, it was the fire method. And then each of our implementations it's an interface, so it implements the interface. So these are just each of our implementations. There can be you would have at least 2 implementations to use this pattern. But you can have 3, 4, 5, however many that you end up needing to. And it's fully expandable, fully scalable. So if I swap this out, you can see all of the variables have been replaced by what we personally set up. So we have our firing weapon, our firing behavior, and our fire method, which was in our update. We could call it do fire to separate it from this one. That's just semantics. That's just personal preference. So you can see our firing behavior interface with our fire method, and then our single fire, burst, and full auto all implement the interface and their method for fire. Like I said before, our firing behavior had initialize as well, but that's just because we were working in Unity and isn't critical to the actual strategy pattern. Hopefully this gives you an idea of what the strategy pattern is and how you can use it. Before we go, I'll give another example just to say yeah, okay, that worked in an FPS. Where would I use it in another game? So for a different example, or how this can be used somewhere else, is in chess. Every chess piece, if you've never played chess before, every piece on the board has a different movement. You know, the rook only moves in cardinal directions in straight lines. The bishop only moves in a diagonal direction. The king can only move one square in any direction. You know, queen can go any direction for as far as she wants. Pawns specifically have one or two moves based on, you know, where they are in the game. So you can see as a hurdle, you can see that, like, in order to we have a bunch of variations of move sets that we need to implement. And so a straightforward way to implement them in chess is you could just make a knight class, and then the knight class can say, you know, do move or something like that, and it'll move in an L shape. Or, you know, you implement your rook class, and then, you know, we say, okay, we can move as far as we want in a cardinal direction. But the problem where that comes in is then when you have to start interfacing with those classes, you have to know what class you're interfacing with to call that move method. So when you do it, you have to be like, all right, I selected a piece, you know, is this piece a type of knight? Is it a type of rook? Is it, you know, type of queen? And then call queen.move or knight.move. But what we can do is we can take all of those back out. We can make a simple interface called, you know, chess move, and then implement a move method, and then we have one single class that we'll just call chess piece. And every chess piece will have a chess move interface, and it just says do move. So then when we create the pieces at start, we just say, okay, I selected a chess piece, do your move. We don't care how it actually moves. We just care that it's doing the move method that it needs to do for that one. And specifically on, like, a pawn, if a pawn has not moved yet, it can move 2 spaces, where every other time it can move 1, and if it's attacking, it moves diagonally. Pawns, of all things, are kind of very dynamic move sets in the game of chess. It has 3 different ways it can move, and so we can just swap out the way that it can move. You know, we say, you know, by default our pawns will have a 2 move behavior. Once that happens, we say, okay, well, we need to reset you to a 1 move behavior. So we just swap it out at runtime. Easy peasy, no problem. This could be done in a card game. An RTS would work too with production of units. The strategy pattern is used everywhere. You can use it everywhere. You could come up with a way to use it in every single game, and that's the beauty of design patterns, is that they are proven examples of code structures that work in multiple situations, and you know what you're going to get. Like, they've been around, they've been used and implemented plenty of times and kind of been stress tested. So it's like the wisdoms of all of the people that came before you that are like, this is what I have learned. Please use this. Please learn it. Please expand upon it. That is the strategy pattern. I hope you have learned to implement it and will make use of it in your own games to help structure your code.